Okay, welcome back, everyone. Let me talk about our schedule for this week. I sent you guys a text remind that I was going to push the test back, so we have today and tomorrow to do test review, and then our test will be on Friday. Okay. Help sessions. I'll have help session today. Well, actually, well, it was going to be this morning, but I can also do help sessions during advisement today, tomorrow, and Friday, and then Friday morning, 7:15. So, okay. I gave you guys a handout. You guys pick up the formula sheet up here. So this is just a reference sheet with all the formulas on it. I crossed out the ones that we don't have to worry about on the test, but these are still good for as we review when we get to reviewing for AP exams. And also the arc trig derivative rules, we can cross those out as well. I forgot to put this note at the top of your sheet, but I think this is always a good habit of whenever you get to a test that you're writing these 6 rules, you're writing the 6 trig derivative rules at the top of your page. That way you have references not only to your derivative rule, but also to your trig integral rules. I think that's a really good habit, especially even on AP exam. That's the first thing that I would want you to do when you get your AP exam non-calculator portion is you write these 6 rules at the top of the page, and that way you can always reference it if any of the integral or derivative rules show up. And it's especially good for integral rules since you know, we don't have, most of us don't have integral rules memorized, but it's fine as long as we know how to work, how to find them using our derivative rules. Then that's that's all we need to do, I feel. And then on the next page, I have a key for a practice sheet. If you want to do some practice on your own in terms of see how as you prepare for your test, you know, with these, I have the derivative rules on one page and I have the integral rules on the other page. Just, you know, just for your practice, if you feel like you want to, this proves to be useful as you prepare for your test for Friday. Okay, so here are the test topics. I have it written up on the board as well. And this is also on my website. And I'll send you guys a remind with these things spelled out. Here's what's going to be covered on your test. Being able to solve differential equations. We've been working on that. That's been our main focus. These past review days is being able to separate our variables, take our antiderivative, solve for C, solve for Y, and hopefully we're getting more comfortable with that. Tangent line equation, this simply finding order pair, finding slope, point slope form, and putting into equation line. We'll do one of that today. And then linear approximation. It sounds complicated, but all you're doing is you're taking the decimal that they give you and plugging it into the x value of your tangent line equation. So just a one-step process, linear approximation. Okay, so the name says it all here. Linear, you're using your tangent line, and then you're approximating using a decimal. So you're inserting a decimal value into your linear equation. Creating slope field. I think we did that last Friday, where it's just where you're given a set of ordered pairs, you identify the location of that ordered pair, plug into your derivative differential equation, and then you're either going to do a positive slope segment, a negative slope segment, zero slope, or what's undefined. Undefined will be what? Well, that's what we want to do, but we should actually do what? Leave it blank. Yeah, leave it empty. Right? If you do a vertical line for undefined, then that's considered incorrect. Okay, so if it's undefined, you just leave it blank. Slope field with differential equation, multiple choice. We'll practice some of that today. That was the page 11 through 14 that you guys did for homework one day, where you had to match the differential equation with the slope field. The y equals e to the kt word problem, creating all your ordered pairs, and then solving for c, solving for k, and then using your calculator to get to your final answer. Inverse trig integrals, being able to complete the square. We know that there is an inverse trig integral involved when you see a gap in your degrees. If the denominator degree has a gap of 2 or more from your numerator, you know that's a good indication that there's going to be inverse trig. So for instance, if I had like integral of 3 dx over x squared minus 5x plus 13, this is a good indication of inverse trig integrals, because the degree in the denominator is higher, and there's a gap of degree of 2. So there's degree 0 versus degree 2. If you see a gap of 2 or more, that's an indication that inverse trig should be able to handle it. And then sometimes when we have to complete the square, like this one, we got to get the 2 sets of parentheses to show up. We'll do some practice with that. And then finally, your quiz topics, those will also, you're also responsible for them for the test. So such as integral of v to the x, integral of 1 over u du, u substitution, synthetic division. Synthetic division looks like this, where you have integral of the right, where the degree in the numerator is higher than the denominator. I mean, there can be a gap, it doesn't have to be, but then we create our half blocks, find our factor, and then after we go through that whole process, then we still have to find our antiderivative. Usually it's going to be power rule for the first few terms, and last term is just going to be natural log. And trig integrals involving natural log. Any questions about test topics? Okay, let's go to our test review. I think, did we finish on page 3? Did we finish number 2? Oh, we didn't start it. Okay. Okay, good. That's right. That's right. We did number 3A. Okay, good. So let's go ahead and start on this. It says on the axis below, sketch a slope field for the given differential equation. So find, for instance, if I start off with this order pair here, -1, 3. Plug -1, 3 in for the x and y of a differential equation. In this case, I will get 1 times 3 minus 1, so 2 times 1, which is 2. So that's going to be a positive slope.
So you have 2 extra sheets of it.
Yeah. What else need the test review? Oh, that's just the location of this point. Isn't it? Like 1, 1, 2, 3. Yeah. And then identify the next order pair, plug into your differential equation, and then just translate that number into either a positive slope, zero slope, or negative slope. Okay, go ahead and try that. I've got keys for all the problems in here, so you can always double check your answer as you move, as you any questions on how we're getting these slope segments? Okay, next part.
You plug it into like the equation.
Yeah, plug the derivative equation. Whatever number you get back in return is a slope number, and you just translate that slope number into a slope segment.
Are you grading them by like the steepness?
Not really. Yeah, if you just give me positive, negative slope, zero slope. The biggest mistake students make is undefined slope. They want to put a vertical line. So just make sure, I mean, there's no undefined here. Why is that?
No.
Yeah, there's no variable in the denominator. But if there's a variable in the denominator, we want to make sure that any order pair that's associated with that, that's causing the denominator to be zero, is left blank. Yeah, calculator. Okay, part B. It says, while the slope field in part A is drawn at only 15 points, it is defined at every point in the XY plane. So we should kind of imagine that, you know, this is, the slope field is not just restricted to these points, right? It expands out in all directions, out to infinity in all directions. So it says, describe all the points in the XY plane for which the slopes are negative. So let's look at our differential equation here. What order pairs, or what are some conditions that's going to force the derivative to give us negative? When y is negative, okay, that's a good start, but let's be, but that may not cover all the cases. What x and y values can we say is going to create? Good. Okay, so that's one thing, and y is less than 1.
The x will always be positive because the square.
Almost. Except what? There's one case when x is not positive.
And 0.
When it's 0, right? So that's the other condition, right? Our when y is less than 1, that's true, right? If it's like 0.9 or 0.8, anything less than 0.99999 is going to produce a negative slope. But just because y is less than 1 doesn't mean that it's always going to be negative. We also have to watch out for the x as well. We can see that anything on the y-axis, even though that's considered when y is less than 1, that's a place where the slope is not negative. So y has to be less than 1 and x can equal to 0. As long as you meet those two conditions, everything is going to be a negative slope as long as it's less than 1 and not on the y-axis, basically. Okay.
X is not equal.
Right, x is equal to 0. So when these two things are true, then we know that the slope will be negative. Okay, part C, find the particular solution. So we have to solve this differential equation, right? So let's see if we can go through our steps. Cross multiply, and then separate your variables. Y is on the left, x is on the right. Take your antiderivative. Decide whether is it natural log, is it power rule, is it use substitution. And I'll walk through the steps after you guys had a chance to try these. And then don't lose the parentheses just yet. We talked about how differential equation, the parentheses are not there to this, they're not there to throw you off. They're there to help you. Okay, so hold on to those parentheses until all your variables are separated, and then you can drop the parentheses if you want. Okay, let me just see how you guys are doing with this. That's fine. Yeah. Oh, and then solve the equation here. So you can just take here. Yeah, cross one, yeah, and then put that over one. Separate the variables and they divide it. Substitution. Okay, so here are my initial steps. I forced the 1 below the x squared y minus 1, so I can line up my diagonals. And then I'm going to cross multiply, so multiply the diagonals with each other. And then once I multiply the diagonals with each other, I see that my dy dx's are locked in place. Those are not going to move. If I'm moving anything, I'm moving things around it. So I see I don't have full separation yet. Looks like the y's are out of place. So I'm going to take that y minus 1 and divide it over to the left side. So that parentheses is helping us because if we want to move that y, the parentheses is reminding us that we got to move that minus 1 along with it. So we divide by y minus 1. Now we should have full separation of variables. All the y's on the left, all the x's on the right. Okay, so once we have full separation, then we have to decide what rule do we want to apply. Right side is easy, that's power rule. Left side, we got that, there's this group of terms in the denominator. Let's go through use substitution, but we should see that maybe it's going to lead us to that 1 over u du, that natural log rule, right? Okay, our u value is y minus 1. Derivative du over dy equals 1. dy equals du. We make our substitutions. Y minus 1 gets replaced with u. dy gets replaced with du. We're left with 1 over u du. That's a nice rule that we recognize. Natural log absolute value of u. Replace the u back in terms of y. And now we're done with the calculus, right? So this is the result of the left side. The right side is power rule. Now we're ready to go to our cleanup stage, which is two things left to do: solving for y and solving for c. With the natural log there, I'm going to solve for c first. Sorry, solve for y first, get that natural log out of the way. I can raise both sides with what base? The left side cleans up. The right side I can split up into multiplying two separate expressions. I know e to the c is just times c. Pull that c out in front, drop the absolute value. So at this stage, I've solved for y because I've dropped the absolute value. The plus or minus gets eaten up by the c. Add 1 to both sides, and now my final step is to solve for c. So 0 inserts for x, 3 in for y. We solve for c, and then we update the equation, and we can call this general a particular or specific solution. Okay, next part, part D says find the equation of the line tangent to the function at the point where x equals 0. So tangent line equation, this is a first semester topic. What information do we need to get tangent line? Okay, we need to find the slope and the order pair, right? So what's our order pair going to be? There's something somewhere else that gives us that order pair? Yeah, 0, 3. There's our order pair. Yeah, so if I want to find the tangent line equation, I just basically need enough information to plug into my linear equation. So I need my order pair. I need my slope. So I have my order pair that's given to us, 0, 3. How can I find my slope? Yeah, plug into which equation? Yeah, dy dx. That's our slope formula, right? So 0, 3, 0 in for x, 3 in for y. What does our slope end up being? 0. Yeah. Okay. So you take your order pair and your slope, put it into your point slope form. All this wipes out, so y is equal to what? 3. So this is our tangent line equation. Now, normally your tangent line equation is going to be a little bit more involved than this. This is just going to be a horizontal line. So there's not going to be any changes with my approximation. So normally I would have to plug into 0.1 in for x and get some decimal value. But in this case, my equation is so simplified that if I try to plug in 0.1, I'm still going to get what? still going to be 3.
Can't you just use like the equation we solved in the other one and just plug 0 in? Like y equals 2e. It's like you can still put y equals e.
Oh, you mean plug into this equation here?
Yeah. Why can't I just put 0? Second one.
Yeah, we should. Exactly right. But let's say you made a mistake here, then you're going to get something other than 3. So I would just rely on what's given to you. But you're right. I mean, you should be able to plug in. That's a good way to double check. Yeah. Okay, so this may not be a perfect example in terms of what you may see on the test. You know, if the tangent equation was, let's say y is equal to 2 times x minus 4 plus 5, then plugging 0.1, you're going to get a decimal. So 2 times 0.1 minus 4 plus 5. Okay, so I want to make sure that we are comfortable with the equation, tangent line, and linear approximation. Right, you build your tangent line equation, and then whatever decimal they give you, you plug into the x, and that's your approximation. This is just an example. This is not part of the problem. I just want to make sure that not all of your equation will be as simple as this. Usually it's, something that has a slanted line as your equation. Okay, let's look at some antiderivative rules. So let's go to page 4, and let's do the bottom half. Okay, so number 4, we can't expand this, right? Power rule, there's too many terms in the denominator. How do we know that this is not a U substitution problem? Yeah, there's a big gap, right? If we forget about that radical and you look at that gap in degrees, degree 6, degree 2, that's a big gap. The only way to handle that gap is using arc trig. So which arc trig rule can we use that will best fit that form? Yeah, arc sine, right? Because we have integral of du over square root of a squared minus u squared. Okay, so that's what we're targeting. And we know it's the arc sine and not arc secant because you see the u, the variable portion is the negative portion and the positive portion is the constant. I'm sorry?
Memorizing the arc sine.
Right. So I gave you guys the reference sheet here to help you recognize the rules you want to be able to memorize. So I crossed out all the ones that you don't have to memorize, but all the other ones we need to memorize. So we talked about, now, is there a need for difference of square, completing the square here? There's only two terms here, right? If there were three terms, we may have to complete the square, but this one, we just have to figure out what our A and U value are. So we talked about how when we do our trig, we want to force our parentheses to show up so that we know, so that we're not pulling the incorrect A and U value. And so what can we put under the first set of parentheses without changing the problem? Still a 1, right? 1 squared is still 1, so no changes there. What can I put in the second one, where if I square it, I'm going to get x to the 6th? X cubed. Right. Let's double check that. 3 times 2 is 6. This is the same thing, but we're finding the A and U value that's going to be needed for our problem. Okay, so next, what's our A value? A value is just 1. Just 1, okay. All right, what's our U value? X cubed. Okay, so we have to go through, now and go through U substitution. Our goal is to get our problem look exactly like this one. I mean, we can pull the coefficients out, but once coefficients are outside, we should have our problem looking exactly like our rule. Okay, du dx. X cubed becomes 3x squared. Okay, cross multiply. Okay, make our substitutions. I'll replace these with a and u, replace dx with du over 3x squared. We're hoping that all the x's cancel out. All right, do all the x's cancel out? Yes. There's a leftover what? Third. Okay, do we have a perfect match with the rule that we want to use? Yes, right. So ready to apply our integral rule here. The 1/3 is going to stay. That's part of this coefficient. Arc sine is the only one without a 1 over a in front. The other rules have 1 over a, like arc tangent, arc secant has 1 over a. This one just jumped directly into arc sine, so 1/3 arc sine. Okay. What do we put in our fraction here? X cubed over 1. Yeah, or you can drop the 1 if you want. Call it x cubed. It's fine. Okay, number 5.
See a gap of 2 or higher, do that mean it's marked, or does this have to be 2?
Say it again.
If we see a gap of things, if like 2 or higher, like that, like 4.
Yeah.
Does that feel like?
So if there's a gap of 2 or more, it'll be arc trig. Yeah, one of the arc trigs. If there's no gap, then we have to consider other options. Okay, number 5, is there a well, first off, we can't do expansion, right? We can't just rely on power rule. Too many terms in the denominator. How do we know this is our trig as well? Yeah, degree 0, degree 2. Not only is there a gap, it's the gap in the right places. It's the gap with the denominator being the higher degree and numerator being the lower degree. If it was flipped around, then it's something completely different. It's going to be either expansion or synthetic division. But it's because it's in this form that's telling us that it's going to be our trig. But there's something else going on before we get to our trig. We need to do it with the denominator. The square, right? We got to get the parentheses to show up in a certain way. So square. And can we predict what type of arc trig we're going to be using? Which rule? Arctangent, because yeah, no radical, right? So that kind of gives it away, right? Complete the square. But we know it's going to be arctangent. Okay, so complete the square. We have to put spaces on either side of our constant. Okay. What formula goes into the blank? B over 2 squared, yeah. Okay, what's our B value? 6 over 2 is 3. 3 squared is 9.
Wait, what's the B?
Oh, sorry, say again.
The B value?
Our B value is -6. Yeah, it's ax squared plus bx plus c. So b is always attached to the x.
Always plus or minus.
That's right. Always going to be a positive space and a minus space. Because whatever number we find, we got to make sure we find a way to remove it because we don't want to change the overall value of this original expression. Okay, so now we have to go through our factoring. It should factor nicely. What multiplies to be 9 adds up to be -6. -3 and -3. Okay. We can merge those two to be just what? And then 14 minus 9 is 5. Okay, let's reset. Okay, so we have the u portion ready, but we know we're going to be working towards our tangent. So let's get our both sets of parentheses to show up in the denominator so that we're pulling the correct a and u value. Any changes here? That's just going to be what? X minus 3. And then what's going to be here? What's squared will be equal to 5? Root 5. Okay. Okay, let's go through our u substitution. What's our a value? Root 5, yeah. And our u value is sometimes they may be flip-flopped based off of how we present it, but remember our u value is always going to be the variable and our a value is always going to be the constant. So yes, the rule does say a squared plus u squared, but it could very easily just be u squared plus a squared because the order of the terms are not important, but we have to make sure that we know how to pick the A and the U value. Sometimes it's first, sometimes it's second, but the U has the variable and the A is just the constant. Our U value is what? -3. So we find our derivative, which is 1, dx equals du. Make our substitutions. Looks like I don't have any leftovers. Okay, so I can jump into my rule. What comes first? Something else in front. What if I wrote it this way? Yeah, that the -4 is not part of the rule, but it is a coefficient, so we need to include it as part of our answer. So -4 times 1/√5, right? 1/a. Arctangent of what's our u over a? Let's see. Or can merge it together. It's up to you. Radical in the denominator is fine. No need to rationalize it. Okay, number 6. Does anybody still need this? Okay, kind of a messy problem here. But can we see through this mess and kind of, I mean, obviously U substitution is needed. But it helps if we can kind of visualize what this could eventually end up looking like. What do you think? What rule do you think we can work towards with the way that this is set up? Yeah, there's a hint there. This is exponential function base 9. So this is what rule is that? A to the u. And then if our u value is the exponent, then it should produce something that is in, within something similar to this. I mean, obviously with some chain rule here. Okay, so we have an a to the u rule, just like how we used on the quiz. So a to the u looks a lot like e to the u. The original function is going to show up in your antiderivative, but there's a conversion that has to occur. So that's the rule that we're trying to work towards. But if we want to work towards this rule, do you see something out of place here? What's out of place in our problem? Yeah, where does this have to be if I want to use the a to the u rule? Numerator, right? We don't have a rule for this. We don't have a rule for 1/a to the u du. Okay. This rule doesn't exist. So if we want to force this into something that we can use, we got to bring that 9 to the top. So if that 9 comes up to the top, how can I make the adjustment? Make it a negative exponent. Okay, so we'll rewrite the problem in a form that is more helpful to us. So now this should fit more closely with what we're trying to do here. What's our U value? More than that. If we let the U value be just 2x, then we're left with a to the negative cosecant u, and we don't have a rule for an a to the negative cosecant u. Our U value has to be what? The entire exponent. What's the entire exponent? Negative cosecant 2x, right? We can't leave that negative out, because if we leave that negative out, then it looks like a to the negative u, and we don't have a rule for a to the negative u, right? We have such restrictive rules there that if we want to use this rule here, we got to make sure that everything matches perfectly. The only way to do that is if we force the entire exponent to be the u value. Okay, so this is one of our original derivative rules here. What's the rule for cosecant of u? Yeah. It's already negative, so we need to include another negative, right? Okay, so negative cosecant u, cotangent u times what? Times u prime. There's a chain rule portion there. Okay. So two negatives become positive, but I'll show that process there. Negative cosecant u, cotangent u times u prime. Two negatives become positive. I can cross multiply. Right. It's good. It's good this produced such a large derivative, because we need something to counter what we see here, right? Okay, we're ready to make our substitutions. Replace the exponent with u. All this should eventually cancel out.
Oh, okay. You because of the same thing.
It is, but we're having to pick and choose. We can pick and choose how we assign the u value, because if we let this be the u value as well, then our rule, then it's not going to match this rule. Then we have a to the u times u, and it doesn't quite fit, right? So just because we see something that is same as the u value, we may not have to include it as part of the u value. Just depends on whatever is going to make this puzzle work, right? So we can pick and choose. So in fact, we're saving this cosecant 2x for the du dx to be canceled out. So most everything cancels out, but there's a leftover what? Good, -1/2. Can that -1/2 merge with a 9 and make it 9/2? Yes or no? No. Okay, this is not a 9. That's a 9 raised to an exponent. This is a function here. So that 9 is not the same as just a 9. It's not a coefficient we can pull out. That's part of a function there. Okay, so our rule is a to the u, so the -1/2 stays. 1 over natural log of a, so 1 over natural log of 9 times a to the u plus c. Right? I can do a little bit of cleanup here. That's my coefficient. A to the u, that's 9. 9 raised to the u. Plus c. Okay, we'll continue with our test review tomorrow. Help session advisements today, tomorrow, and Friday. Okay, all right, come get your phones. Yeah, help session. Yeah. So if you want to take a picture of that on the board, you can.
We're doing more reviews tomorrow.
Yeah. What time do you want to do it? All right,
This is the homework where I.
okay, great, thank you.
Tomorrow, because I won't be around.
What do you want to do?
I do doing advisement or thing.
Yeah, for work.
Okay,
Okay, thanks.
Either,
Either,
okay,
as long as you make sure that you have enough time to take the test and that your teacher doesn't mind you. Oh,
okay,
wait,
yeah.
this is third,
I have third lunch, so,
okay, you take during third, we can
Okay.
advise, it's up to you.
okay.
Yeah,
thank you.
I'll take the test tomorrow.
That's about there. Do you guys enjoy my light bulbs?
What?
You guys enjoy
I'll be
my
here
light
Friday
bulbs?
morning, but I'll be
I gave out. I got
like afternoon, like I have a doctor's appointment in the morning. So can I take like 5th or 6th?
We have Mr. Cummings.
On Friday? Yeah.
Okay, see if I'm caught up on my. You get him out.
Oh,
I wouldn't be here on the trip.
What?
yeah, you're good.
I couldn't be here.
Okay, thanks.
Which Chick-fil-A do you guys go to? Oh, okay. How's your weekend, Jay?
That's good. Yourself?
Yes. Yeah, it was good. We got all spears, LP.